Okay, so this is from page 332 of your book. It's question 19. And in this question, I'm being asked to prove that x plus y equals to 90. The first thing that I notice here is that in my diagram, I've only got a name for one of the vertices. It's O, and it might be helpful for me in a while to have a name for each of these vertices as well. So I'm going to start by actually naming those vertices. So I've chosen to name those vertices A, B, and C. Okay, so now I'm going to have a look at my diagram and I'm going to think about what I can do to figure out information about it. And there's two things that jump to mind here. The first one is that whenever you've got a circle, you should always try and mark in what? What did we say in class again? So you need to mark in every radius. So since O is the centre of the circle, O to A must be a radius, O to C must be a radius, and O to B must be a radius. So straight away now, this lets me know that I've got some isosceles triangles. And so I can fill in some information for more of the angles. So pause the video and see what you can fill in. Okay, so I'm looking at the triangle OBC, and I'm going to say, well, if that's x, and this is an isosceles, that must be x as well. And looking at the triangle AOB, well, if this is y and it's isosceles, this must be y as well. So I'm going to start now by just writing down that much information first of all. So what did I say? I said that AO was equal to BO was equal to CO, and that's because they are radii. And that tells me that the triangle AOB is isosceles, which tells me that the angle ABO must be equal to y. And the triangle BOC is also isosceles. And that tells me then that the angle OCB is equal to x. Okay, so that's just on the basis of marking in the radii. Now I'm thinking about what it is that I want to prove. Well, I want to prove that x plus y equals 90. So let me have a think. Is there any rule involving 90 that might be relevant here? So I'm thinking about theorem 19 and one of its corollaries. And the corollary that I'm thinking about is the one where I have a diameter and then a triangle standing on that diameter. So I know something now about the angle ABC. That angle actually is going to be equal to 90. So I'm going to be able to say, well, okay, oops, wrong marker. But the angle ABO plus the angle OBC equals to 90. And I'll give my reason for that, because I've got a triangle standing on a diameter. But of course, ABO is just the angle y, and OBC, I was given at the beginning, is just the angle x. So therefore, x plus y equals 90. So this question just required me to spot, first of all, the radii in my diagram, and also spot that corollary that allows the angle standing on a diameter to be equal to 90.